As a reminder, cosecant is really just the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is a reciprocal of tangent. Also remember that when we are going to identify the period length, we're going to take 2 pi for both sine and cosine, so also for cosecant and secant, and we're going to divide by the number in front of the x. So I'm going to take 2 pi, for instance, and divide by 1. And I'm going to take, because secant is reciprocal of cosine, I'll take 2 pi and divide it by 1. But when I'm working with cotangents, since the period length of a tangent is identified by taking pi divided by the number in front, so I'm going to take pi and divide it by 1 in this case. We're going to keep that in mind and put that up there on top. Okay, let's get started. So I'm going to focus in on sine. Now when I look at my unit circle, remember that sine is always the second number in the ordered pair. So at 0, the output for sine is 0. Now 0 can also be written as 0 over 1. So when I take the reciprocal of sine to achieve the cosecant, I'm just going to flip this fraction. 0 over 1 flips to 1 over 0. We can never have 0 on the bottom of the fraction, and that's why I'm going to have this vertical asymptote at 0. Let's go ahead right now and let's identify the period length. So I take 2 pi and I divide by the number in front, which is 1. That gives us a period length of 2 pi. Now to figure out the x scale, since cosecant is really going to be the reciprocal of sine, I'm still going to divide it by 4. In fact, all of these I divide by 4 because there's 4 steps. So I'm going to divide 2 pi and I'm going to divide it by 4 to get pi over 2. Pi over 2. All right, so each one of these steps along the horizontal axis is a distance of pi over 2. So I'm at 0. Let's go to pi over 2. Now at pi over 2, which is equivalent to 90 degrees, we have, at this point, we have a sine of 1. So if I take 1 and I flip it, I still end up with 1. So I'm going to go over and I'm going to go up 1. All right, now let's go another distance of pi over 2. That means an additional 90 degrees. So we're here, we go additional 90 degrees. I end up at 180. I'm going to locate what the output for the sine is. It is 0. 0 is the same as 0 over 1. And now when I take the reciprocal, once again, I get 1 over 0. And we know that that is impossible. So I have, again, a vertical asymptote. Now we need to decide what goes in between these two vertical asymptotes. I have a point, but what is the function after? What I'm going to do is I'm going to come back to the unit circle. I recognize that this is, if you want to think in terms of degrees, this is 0 and this is 180 degrees. This is 0 and this is 1 pi, right? So I have gone through and this resulted when I took the reciprocal in a vertical asymptote, in a value of 1 and in a vertical asymptote. So I want to choose any number in between this, and I want to take the reciprocal. Now I know if I take the reciprocal of radical 3 over 2 and I flip it, it is right here. If I take the reciprocal, I have to flip it and I have to make it nice. I'd have to go into a calculator. I know this is a positive number, but I don't know exactly what that is until I grab a calculator. Same thing here. I can take radical 2 over 2 and I take the reciprocal and then I make it proper, but again, I don't know exactly what this is equivalent to. This is pretty easy. If I go just to the right of 0 and I take the reciprocal, again, we're focusing on the sine, the outputs of the sines. If I take the reciprocal of 1 over 2, I simply get 2. So a little past 0 at 30 degrees, or pi over 6, a little past 0, the reciprocal of sine is 2 over 1, or 2. So a little past 0 is 2 over 1, so I have a point right here. Now we need to figure out, does it go down or does it go back up? So let's do the same thing. We know this point of 1 was achieved at 90 degrees or pi over 2. Let's choose another number over here. Again, I'm focused in on the sines. I'm focusing on the sines, and the sines are the second number. CBS, cosine always before sine. So again, I've already gone over why I'm not choosing these two, because even when I take the reciprocal, I don't know exactly or quickly what is that equivalent to. But if I take the reciprocal of 1 over 2, I simply get 2. So just before I get to 180, or that vertical asymptote, when I take the reciprocal, I get 2 over 1. So just before I get here, I get 2 over 1. All right. So now let's keep going here. Let me bring this I want you to recognize that this is not one cycle. I've gone over, if you want to think in terms of degrees, this is 0, 90, and 180. 0, 90, and 180. 0, 90, and 180. And you're thinking, well, why aren't you done? And by the way, remember, we do it in terms of radians. So it's 0, 1 pi over 2, and 1 pi. And the reason I'm not done, and I know this is not one cycle, is that one cycle is a distance of 2 pi. So to go to 2 pi, I've only gone halfway. I need to go all the way out here, because this would be 0. If you want to think in terms of degrees, if that helps you, 0, 90, 180, 270, and 360. Or in terms of radians, which we need to train our mind to do, 0, 1 pi over 2, 1 pi, 3 pi over 2, and 2 pi. So I need to keep going. So I've gone here. Think of this in terms of compass. I've now gone north. I've gone west. Okay, now I need to flip down here and go to the south. This is the value for sine. When I take the reciprocal, because remember it's really over 1. When I take the reciprocal, it still ends up being a negative 1. So when I go one more over, I get a value of negative 1. And now I complete 2 pi. I'm focusing on the sine. So it's 0 over 1 right now. When I take the reciprocal, I get 1 over 0. We can't do that. And we have another vertical asymptote. Now, I need to find out, just like I did up here, how do I know if it goes up, if it makes this little twist down to the left or twist down to the right, or if it both goes down? Because this will complete one cycle when I'm done. Okay, so I'm going to choose a point between 180 and 270. So in this third quadrant, I'm going to focus on these three values, and I'm going to ask myself, which one can I quickly take the reciprocal of and know the value? So if I flip these two, again, I have radicals, and I don't know exactly what they're equivalent to if I'm going to graph them. But if I flip negative 1 over 2, I get 2 over negative 1. And 2 over negative 1 is equivalent to negative 2. So just slightly past 180 or 1 pi, 180 degrees or 1 pi, is a value of negative 2. So this is 180, also known as 1 pi, and just slightly after it, I can go down to negative 2. Now, I can make the assumption that if this went up, this is probably going to go down, but I still need to know that. So once again, this is 0 if you want to think in terms of degrees. This is 90. It's at the north, if you think of it as a compass. This would be the west at 180. This would be the south at 270. And this would be the east at 360. Now, I need to know what to do. So I'm going to look in quadrant number 4. In quadrant number 4, I'm focusing on the sine values. Here are the sine values. And right away, I can see this is the easiest one to take the reciprocal of. Negative 1 over 2, and when I take the reciprocal, will be negative 2 over 1, which is negative 2. So just before I get to 360 or get to the next vertical asymptote, I have an output value of negative 2. So I'm going to come over here, and just before I get there, I have an output value of negative 2. This is one complete cycle. So now all I have to do is I just need to continue to copy this. I'm going to press pause and make the vertical asymptotes every 2 steps in between. And then I'm just going to keep copying this pattern. So it went up and went down. That's one cycle. So this one goes up. And this one goes down. So now I've done 2 cycles. And now I'm going to go in the opposite direction, continuing the pattern. So this starts here, and it's going to go down. And this one will go up. And this one will go down. And this one will go up. Okay, now let's look at the maximum. So each one of these is pi over 2. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. So 8 to the right. 8 groups of pi over 2. That'd be 8 pi over 2, which reduces to 4 pi. And I bet you it's 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And a negative 4 pi to the left. All right, that is cosecant. So everything I do with cosecant, I'm going to come back and look at this parent function of cosecant. Remember, cosecant is reciprocal of sine. Now let's focus in on secant.